right, so let's start off. See, organic, my estimation is like this. Your theory is not going to be that much in terms of understanding, in terms of what I've understood. Your teacher at school is very competent. He's very good. So your theory, I don't think there's going to be that much of an issue. Organic, more or less, you're going to be having issues only with problems, interesting problems. So as and when we are having sessions, do not worry about what to say, whether topic is completed. वो सब सोचो मत. If you have any problem doubts, we will discuss them directly, and we will proceed on in that direction from now on when organic is happening, because organic mein your practice is paramount. I think last session itself I mentioned, if you want to the best identifying mark to know if you have made it with respect to organic chemistry is when you start having fun solving questions.
Yeah. Yes.
So that has to be your end game ideally. So practice and more practice. And let me start off with this now itself, so that you can keep an eye on it when things are happening. When you are learning organic chemistry, you have to treat it like inorganic chemistry in the beginning, but then apply your brain like physical chemistry. In a sense, in the beginning, you do not have any data in your brain about organic chemistry. So you will have to treat it like inorganic chemistry in the sense you'll have to memorize the data.
Memorize everything. Yeah.
Properly in the first place. Once you start making connections, then you can forget. Inorganically, you'll have to remember the marker points anyway, but organically, even that you can more or less to some extent forget, because it will connect to everything else. But initially, you will have to sit and memorize properly. It will help a lot. So from that point of view, what you should be doing is this. Abhi ke liye, there is no issues at all, because this is general organic chemistry. But when the chapters start happening, every chapter in organic is going to be a cumulative chapter only. There is no standalone chapter. That is the biggest problem which children face when it comes to organic chemistry. So if you're looking at the kind of problems which normally students end up facing, the real issue happens when, first 2-3 chapters, they'll be comfortable. But when it comes to the 4th or 5th chapter, when it comes to alcohols, phenols, ethers, aldehydes, ketones, what happens is you will need to know about alkenes. Without knowing alkenes, you can't touch aldehydes, ketones, because in the question, they are never going to be asking you only on aldehydes. There is no question which is going to be made like that. They are not idiots. So you will have to start realizing the way to play the game in organic towards the end will become like physics, where you have to start connecting Newton's laws of motion, friction, and center of mass and everything, and then get to rotational dynamics. That is how organic in later parts is going to be. But organic in the initial parts will feel like inorganic chemistry.
Yeah.
So when you are learning chapters like hydrocarbons, make sure you are making a good synopsis.
Yeah.
As and when, even now for GOC also, make a good synopsis.
Yes. Yeah.
What is a synopsis? It's literally a bit sheet. Yeah. If you're allowed to write the exam in an open book manner for this particular, for whichever exam, what would you like to take? And you're not allowed to take too much stuff. You're only allowed to take bare minimum, which you can take, you're allowed to carry. Think of it like you're allowed to carry what you can smuggle inside your underwear. Nothing else. So it's just they're not going to catch you.
Yeah.
You can imagine it like that. So literally, jo tu bit mein likh sakta hai, that is going to be what you have to basically minimize the thing. Refine it as much as possible as to what is required for you to remember, and then go with it. Okay, now let's start off. So what has happened in organic for you in this current set of days?
So we finished geometrical isomers, and we today started optical isomerism.
Okay, so you have done configurations to some extent then.
Yeah.
So all right, so give me a quick blow by blow as to what all you have learned in this time. Geometrical, what were the key examples you guys saw?
Sir, we saw in first of all cycloalkenes,
Hmm.
and then
Cycloalkene.
yeah, kene.
Cycloalkene, there is no geometrical isomerism. Cycloalkane, there is alkenes you have seen. And I am assuming, what is that other, what to say, E and
Ketoxins. E and Z also we did, yeah.
okay. And cycloalkane basically includes all cyclic.
Oh, okay. Sir, why doesn't cycloalkene show? Right.
We will get to that when we get to it. We will talk about cycloalkene. Since you have mentioned that, I'll discuss that also. I'll talk about why that doesn't show.
Oh.
I think sometimes I end up giving unnecessary extra information, which makes you have more questions. So, yeah, next. ENZ okay?
E and Z, yes, done. And then
Then you have done Khan and
small
Gold.
Khan. Oh yes, yeah, we done that. Yeah.
Okay. This is very
And
important. Khan
then
and Gold. And what else?
calculation. Wait, sir, what do you mean by Khan? Like,
The rules
oh, the
for
rules. Yeah, yeah, yeah.
priority.
Priority, yes, we've done that. Yeah.
Uh,
And then
okay.
calculation of number of geometrical isomers.
Number of geometrical isomers.
Yeah.
Okay. And
And optical
mm,
isomers.
you did syn and antioxide
Yes, we've done that. Yeah. And spiranes also we did.
and
Spiranes.
spiranes. What are these?
Like multiple, like it's like this
Draw it
algorithms.
and just show me a photo or just show the camera on that.
Like like this.
Oh yeah, so those are called spiranes. Effectively, MS Chauhan. Okay, ठीक है, fair enough. Okay, I just put that's.
And then fused bicyclic compounds.
If you have done this crap, then have you done diene cumulative?
Yes, yeah, we've done that. Alliums. Yeah.
Yes, alliums. Yeah.
And
Okay.
then this fused bicyclic compounds.
Yeah,
Like
basically, I understand. Once you showed me this thing, I know what you're talking about there. So basically, the entire concept
okay,
related.
okay. Yeah, that's it.
Effectively, you will also have these weird fellows. What are they?
Yeah, yes. Oh,
This kind of crap, no?
yeah, but then like we didn't do many examples with
Yeah,
yeah,
they're all
some
effectively your teacher was covering his ass. That's all. Nothing else. Your teacher never meant to give you a proper, what to say, full-fledged crash course of that. He just wanted to make sure, what to say, exam if it shows up, he's made it clear that, yeah, this can show up. You've been touched upon that. Good. He's a very good teacher. I really appreciate that. See, this is the mark of a good teacher. Someone who knows, but the problem is this. It doesn't matter how good you are. The system is corrupt.
yeah.
And that is the problem which happens once you go high enough up. You start realizing, yeah, system's not, system's got issues. Do you really need these spiranes, these allenes and shit, really? Allenes, maybe yes. These spiranes, really?
No,
No. But why is it that someone who is, I can sense your
could
teacher
show
in
up.
your school is very good. In the sense, he's very sincere to his craft of teaching you, you guys.
Yeah,
Basically. And someone like that is obviously clear about the fact that this is never going to show up.
yeah,
But that person is teaching you this.
yeah,
And you remember what I told you about inorganic in the beginning. The more junk you keep in your brain,
yeah.
the more difficult it becomes to make the meaningful connections. It becomes irritating when you start seeing the system like that. And how old is your teacher?
He's like 40s, somewhere in the 40s.
End of 40s.
No, middle mid-40s.
Middle.
Yeah.
All right. Let's get to it. So this bunch you have covered. What else have you covered then?
So optical.
Optical. Before optical, you'd have done some touch up, na? What all?
Uh,
Formations and
like,
configurations. Which configurations did you do?
sir, we didn't do any configuration.
Okay, maybe the nomenclature which I'm using is different here. Did you do sawhorse projection?
No.
Okay. What did you learn in optical isomerism? What did you start off with? How did you start off?
Well, we just like wrote down like the definitions and all. That's about it. Yeah.
Give
Nothing
me the
much in.
definitions which you learned. Quick blow by blow.
Uh, Compounds with the same molecular formula. Wait 1 second. Yeah, compounds with the same molecular formula and structural formula, but difference in the direction of rotation or degree of rotation of plane polarized light are called optical isomers. Yeah.
Okay, your teacher is going the clean way. Let him finish. I don't want to poke here. Then. So he is taking the correct approach here, and yeah, let's not touch that now.
Okay.
I'll let you finish it, then I'll do my poking. It's not good
Okay.
to poke before things are clean. Or if you have some doubts about that, which you have already discussed, which is already talked about, and you didn't understand clearly, then you can ask, did you learn plane polarization? What is meant by plane polarized light? What is meant by...
Yeah, like initially it's like the light molecule is like vibrating in all directions, I guess. And then when it goes through the prism, then it becomes only in a single plane.
Okay.
Is that
What? Okay, go on. Continue.
and then that these plane like the plane polarized light get projected through a solution of a compound, and then based on whether the compound is inactive, optically inactive, or like the other stuff, it rotates and all like that.
Okay, so sir has already, your teacher has already discussed the basics of what is meant by that.
Yeah,
That
that's it.
is done.
Nothing more than that.
That discussion is done.
Kind of, yeah.
Okay. What did you understand by optical activity then from that?
Like uh like if the compound, I'm not sure, but I'm guessing if the compound is, I guess, maybe non-coplanar, then maybe it.
Okay, so let's break it down slightly here as to what's happening. So effectively, what's happening is something like this. There are a couple of parts where I saw that your understanding had some gaps. Let me just hash out on that. First was, what is unpolarized light? So what is meant by unpolarized light here? So when you take a light wave is what is called as an electromagnetic wave. All right. So what does an electromagnetic wave mean? It means if I'm going to be considering it as a wave, the wave is going to be something where it is oscillating in 3 dimensions, where one
Yes,
dimension is going to be having the electric field oscillating, one dimension
magnetic
is
field.
having magnetic field oscillating, and in the other direction, you'll end up having the direction in which it is moving.
Velocity.
Oscillating.
Yeah.
So you're going to be having 3 parts to the light wave. One is going to be your electric field. Let's say this is or let's take this guy's electric field here. My index finger is electric field. Let's say my middle finger is going to be representing my magnetic field. Actually, no, index finger I'm taking as direction of propagation towards you. Basically, I'm having a light beam. I'm shooting it towards you. So
Yeah.
direction of propagation, electric field is my thumb. Magnetic field is my middle finger here. So this is going to be a light wave, which is going to be technically only one piece. If I'm somehow isolating one wavelength of light or whatever that, I mean, one individual photon, it will technically be like this. But in general, you are never going to be having one photon. So what happens is you're going to be having a beam of light. So when you have a beam of light, what that means is you're going to be having these waves are technically going to be, 1 second. Yeah. So effectively, you're going to be having this as a light wave. So what happens over here is you're going to be having the light wave as it is moving towards you is going to be something where each of these three have to be mutually perpendicular to each other continuously. But I'm going to be having it technically present in all directions like this. As long as the direction of propagation is going to be the same. If I'm shooting a beam of light here from a torchlight to you, the direction of all the beams is this way. So direction has to be this, but the electric and magnetic field are possible in every direction. So what happens is, if I'm going to be taking, say, something which is going to be called, what to say, a Polaroid. I don't know spelling and all for that. I'm assuming this is or polarizing. Nicol prism is a typical goddamn example. So let me go with
Nicol prism.
So if I'm going to be taking a Nicol prism or your modern sunglasses, most of the sunglasses that we have are all polarized glasses now. What happens in that particular case is you're going to be having this particular type of light where you're having all of this in every direction. Electric field and magnetic field are in every direction possible, while direction of propagation is one, is going to be called as unpolarized light. What this Nicol prism is going to be having is, it is going to be something where there is such a unique structure for that system where it is capable of physically creating a shadow on a particular direction, and it literally physically cuts off a chunk of the light by absorbing it. That is literally what happens. How is basically, think of it like this. If I'm going to be having, say, there's a light over here, obviously, right? You can see that in this case here, this part of my face is looking dark. Why?
Dark, yes.
Why?
Because light doesn't directly fall on it.
Exactly. Why? Because it's in the shadow. Correct? It's in the shadow of this side's light. You can see this part very clearly because there's a light over here, obviously. So when we are talking about a shadow, literally the shadow is a part where the light is cut off, correct? The Nicol prism is something where at the crystal level, at the molecular level, it is able to apply a shadow. That is the best analogy which I have about that. I don't exactly know how it is cutting off. My understanding is at that stage, it will go into quantum mechanics. And it's going to be relatively unsolvable beyond a point. It is going to be very complicated. I will probably not be able to understand the math. But in a sense, the best way to imagine it is, you can think of it as, it is literally creating a shadow. It is literally absorbing a part of the light. So why is it that this shadow is created over here? Because my skin has absorbed the light waves, correct? Chunk of it is reflected and it is what you're seeing, but a bunch is definitely being absorbed. Correct? So that is basically what happens over there. So when you're going to be having a Nicol prism, the internal structure of that thing is going to be something where it will actually be able to create a shadow at things. Now, forget about how it does that now. That doesn't matter, honestly. Let's talk about what it is doing now. So what it does is, I'm going to be, this part you got it correct. So let's directly talk about what's going to be happening here. Usually what we'll be having is, we'll be having a tube. On one end, we will be having this, what to say, Nicol prisms, polarized. Give me a second, dude. My friend is calling me. Let me just mute you for a minute. Yeah, sorry, dude.
Yes.
Yeah, so where was I? Yeah. So let's say I'm going to be having a Nicol prism, a polarimeter, a Polaroid taken here. So what's going to be happening is, let's say this is going to be what is called as a vertical polarizer. Now, honestly speaking, I do not know what the hell a vertical polarizer is supposed to be exactly defined as. It could be that it cuts off the vertical, or it only allows
keeps the vertical.
I don't really care what the definition is. I'm going to choose one and go with it. It's a 50-50 choice. I am not interested in debating that choice. All right. So now,
Yeah.
so there is going to be a polarizer available, which is basically a lens. What's going to be happening? I'm going to be shooting some light through it. When I shoot some unpolarized light through it, the original electric field, let's say was my thumb, it was going to be in all directions. Now, when it is passing through, this guy is going to be allowing only the vertical component of electric field to pass through. Meaning, anything which is going to be tilted like this at an axis, let's say. What happens is this particular electric field is in this direction here, correct? So this guy's vertical component part alone will be allowed to pass through. The horizontal component part of it will get absorbed away.
For the other one also, right? The other finger.
Any piece which is passing, let's say something like passing like this.
Then the component of the middle and the thumb.
Component in this direction, the horizontal will get taken away, will be absorbed away. The component in the vertical will be allowed to pass through.
Both of them add up. Okay.
No, don't think about what is happening beyond that.
Okay.
See, the mistake you are making is, I told you about your mistakes there, assumptions. I didn't tell you what happens to the remaining there. Don't make that assumption there. Your vector summation from physics tells you, oh, add ho jayega. Nahi. Don't assume. We do not know. Yes, my physics also tells me there is a good chance it will add up, but I do not want to make my mind up over that because I do not know for sure. And I've not done the math over there to understand that shit anyway. This is all conjecture from my part. This is all my understanding of it. So no book will give you this kind of crap anyway. So the fact is, bulk of the things you would have probably realized by now, most of the shit which I talk about, we don't find in books.
Yeah.
So the idea there is books are basically, how to put it, when you have enough to teach or when you have too much content, you will not write a book. You cannot. There's too much in your brain. You will generally be writing the book only when you are much older. So youngsters who are writing books generally, are frictious people who cannot stay properly in one place. And book writing is a way out. Anyway, coming back to the aspect here. When you're going to be having, this Nicol prism here. So this guy here, if it's a vertical polarizer here, let's say it allows only the vertical component to pass through. So if it allows only the vertical component to pass through, I will initially be sending in unpolarized light, which technically will be capable of oscillating in any directions. I will be having what is called as plane polarized light, PPL. That is going to be the abbreviation which is going to be most commonly seen in this part here. It is called as plane polarized light, meaning the electric field and the magnetic field component are polarized onto one plane. Electric field in this case will be on the vertical, magnetic will be on the horizontal. That's the idea here. Now, what is the optically active substance bit here? Let's start off with something from physics first. I'm going to be having two people, person 1, person 2. I'm going to be having both of them technically having a velocity in this direction. Okay. One small problem though, I'm going to tie a chain between them. What will happen now? If this is V1, V2, let's look at the cases. If V1 is going to be equal to V2, what will be happening in this case?
They'll move parallelly.
They'll move parallelly, they'll move straight. If I'm going to be having V1 greater than V2, what will happen in that?
You'll pull that towards this thing. Like it'll end up becoming like V1.
What will be that path?
Like P1 will go straight, but then this P2 will also.
Will they be straight? Think. Don't do math here. Don't do math here. That's the reason I'm giving you an analogy. Think if I'm tying you up to your mother and I'm making you both run. What will happen? So effectively, you will run a little bit more distance in the beginning first.
Yes.
But you'll get pulled. When you get pulled, you'll turn.
Yes, circular. Not circular, but
both will effectively form a chord type thing. Both of you will go into motion which is going to be circular type. Because you're getting pulled is going to make her get pulled also.
Yes, yeah.
So effectively, the motion which is going to be followed will be something like this.
Yes, yeah. That's it.
Right? Not exactly circular, but a huge circle's part. Right?
Yeah.
So effectively, you are going to be having a tilt happening here. Why did you have the tilt happening here?
Because something is pulling both of them, right?
Because these two parts were connected to each other. They were part of the same whole. And this part and this part are traveling at different velocities.
Yes. Yeah.
Correct? So you had a bending happening. So you had an angle being created because of that. Correct? So what was my original path? It cleaved into a different angle there. It made an angle with that original path. Yes or no? This part is properly clear?
Yes.
So if I have a piece which is a part of a whole and different parts of that piece are traveling at different velocities, we will have a bending scene.
Okay. Yeah.
Can I put it like that?
Yes.
Does that make sense to you? You agree with that?
Yes. Yeah.
Now, let's go for what's going to be happening. So in this case here, we are going to be having plane polarized light. Okay. Now, if I'm going to be having one more Nicol prism here. Okay. If I'm going to be having this guy being a horizontal polarizer. First was a vertical on one end of the tube. On the other end of the tube, I'm going to be having a horizontal. What will happen?
So assuming it lets out horizontal or like it removes horizontal?
How does it make a difference? Same definition of vertical Joule, yeah, uska opposite.
Okay.
The vertical, if you look at us, the vertical is kept there, correct?
Yeah.
So we will take this also, it is kept. Yeah, problem.
Yes, that's what. Only the vertical will pass through because there is no horizontal.
Good. So in this particular case here, in the vertical polarizer there, the vertical pass through. Okay. And in the horizontal should pass through.
Yes.
Correct. So after it passed through the vertical, was there any horizontal left over?
No.
No. That means when it passes through the horizontal now.
No. It's like a point.
No, there is nothing. You see black. You don't see the light. It becomes opaque. Correct. You remember what I told you? What does forming a shadow mean? My face is creating a shadow, was creating a shadow here. Why? Because my face is opaque. Correct. Opaque is absorbing.
Correct. Yeah.
So in this particular case here, this guy should be opaque. Correct. If it is a perfect horizontal fellow, it should be opaque. That is the case when you are having an optically inactive substance here. If I fill the tube up with an optically inactive substance, implies this is opaque or empty. So if the tube is either filled with an optically inactive substance or if the tube is empty, I will have the other end being perfectly opaque. Now no light will pass through because there is no there is no horizontal component left over for it to pass through.
Yeah. Yes.
Now, here's the interesting thing. If I have inside this something which is an optically active compound,
It would rotate.
So what is that guy going to be doing? So originally, my plane of polarization was this. My electric field was only in this direction, in this vertical plane there. So when I'm letting it pass through, it will basically get rotated like this. Slight rotation to an angle. This much angle it will rotate it. Because it is now rotated and become at this angle, now there is a horizontal component available. Right. So now when there is a horizontal component available, what can I do now? I will now see some light.
Now, yes, on the back end.
That is why it is called as an optically active substance.
So, but then what does it do to rotate the thing?
Now, we are not done with game here yet, or we're not done with the stuff here yet. So let's continue on. So effectively, it has rotated. Now, let's talk about what is this optically active compound really. This is a compound which has no symmetry, no meaningful symmetry.
Okay.
Now, what does this no meaningful symmetry lead to over here? So when the compound is having no meaningful symmetry, you can think of the compound like this, where there are 4 parts of the compound where all 4 parts are technically different. So effectively, whichever way in which I divide the compound into 2 parts, both parts are never going to be having the same density. Molecular level pe, atomic level pe. Because there are different substances present, there is no symmetry there at all. Now, let's talk about light a little bit. What have you learned about light when it passes through different mediums?
It bends.
No. Is that what you learned?
It refracts.
What? Why does it bend? You learned why it bends now.
Because its speed decreases.
Its speed changes. That's the key point I'm looking for there. So when light travels through a medium, the speed at which it travels ends up changing depending on the type of medium it is traveling through. Correct? So in this particular case here, this is an optically active compound present here. Usually, this optically active compound here will be in the form of a solution. So if it's in the form of a solution, obviously light can pass through it. So when the light is passing through it, now this is where that example we talked about comes in. What is going to be happening? A light wave is like a huge wave passing through. When that wave is passing through different parts of the same molecule, different parts of the wave will move at different speeds now.
Yeah.
Which is in some way related to what's going to be happening there in terms of the bending of the light over there. When they say that the plane of polarization is bending, the light is remaining the same. Nothing changes in terms of intensity. None of that is going to be changing beyond a point. But the plane of polarization gets tilted, which is where that example which I gave you earlier comes into play. So you can think of it as a whole piece is moving, where you're going to be having different parts of that whole piece are moving at different speeds, which creates a bending effect as it is moving through. That bending effect is what is going to be seen as an angle. You measure it as an angle. That is basically what you're going to be having as optical activity. That plane of polarization, which was originally vertical, tilted by a particular angle. That effectively is what's going to be happening in this case
here. Okay.
This is the, what to say, this is the way in which I have basically understood the concept there. But the truth is, my explanation is probably too simplistic. The truth will probably be a lot more complicated. But what I discussed more or less fits all the pieces. So you'll end up having the understanding behind how optical activity is happening is basically this. What is happening? Why is the plane of polarization tilting? This is more or less the rough reason as to why the plane of polarization is tilting. Now, what is the reason why it tilts though? The reason why it tilts is because the molecule it passed through had no symmetry. Correct? Because that molecule had no symmetry, the wave which passed through had different velocities when it was passing through different parts of the molecule at the same time. At the same time. That is the key thing here. Because light ke beech mein you can't talk about, it's the same wave. It's like the same wave passing through the same molecule at the same time.
Yes. Yeah.
But it is getting but there is different velocities though. How will that be reconciled? We can't think about how it's going to be reconciled, because the moment you go deep into that, it just goes completely out of whack.
Yeah.
The idea behind light waves traveling at different speeds in different mediums actually treats the wave as a particle. All right. That is the reason why you end up having it. Effectively, you can say that compared to a vacuum, That's what your dielectric constant and all of that comes into play there. Compare, or what is it? Refraction, what is that constant, man? Mu,
Refractive index.
Refractive index, correct. Yeah. So compared with the vacuum, how much resistance to light is this guy giving? How much resistance to the movement of light is this guy giving? That is what refractive index effectively is.
Yeah.
How much slowdown is it going to be creating, basically? So when you're going to be having light being completely treated as a wave, it goes a little bit differently. So the understanding is what I told you, but the way it is treated mathematically will be different. Now, coming to what is going to be happening here. So the extent of tilting, what will that depend on? So we talked about how the tilt is happening.
How
the plane
how
originally was
asymmetric
this
the
was
thing.
plane polarized light. It got tilted in this angle by some angle theta.
Yeah.
Right?
Yeah.
At start, at final. So what is this tilt depending on? What do you think it depends on?
How asymmetric the compound is.
Obviously.
Yeah.
Other than that, how many molecules it passes through, right?
Yes.
Bluntly, that is the key thing, right? How
Yes.
asymmetric it is going to be the individual compound's property, which
The
we can do.
concentration.
So this theta here is actually proportional to what? It is proportional to number of optically active molecules light wave passes through. Right? So that is going to be something which later on you'll be learning. I mean, I'm sure you'll be doing it in a class soon. This is going to be something which will effectively be proportional to the length of the tube. And it is also proportional to the concentration of the
solution.
Concentration of solution. This is generally taken in grams per ml.
Okay.
Remember, these are all archaic things which were done a long time back. So at that time, the standardization they used was grams per ml, and this was taken in decimeters.
Oh.
Yeah. A little bit irritating, but not that bad.
Yeah.
Now, anyway, coming back to the point over here, you're going to be having this a little bit more in detail being discussed upon in your school anyway. So I'm not going to touch upon that. But this is basically what's going to be happening in terms of optical activity. So the optically active compound, what is special? It has no proper symmetry element, which is meaningful. That is the key thing. So, okay, now let's go back to something other than optical activity, because I think I've covered off most of whatever you have done in optical activity by now, correct?
Yeah, that's about it. Yeah.
So whatever doubts you had till now, I think they should be okay by now. Now you can proceed on for learning in your class properly. Let's go back to the older topics now.
Yeah.